In this video, we're going to learn how to derive the total cost curve when we're in the long run. Let's suppose that Clean Getaway produces artisanal soaps that they sell at the local farmer's market. Their production function is given by Q equals L times K. So it's a sort of a standard and simple Cobb-Douglas production function. As usual, L is hours of labor hired and K is hours of capital hired. We're also told that the price of labor is $40 per hour and the price of capital is $10 per hour. Our goal is to determine Clean Getaway's long-run total cost curve. What do we need to know to solve this question? Honestly, we really only need the production function. If we're lucky, we'll also have a wage and rent value, and that will make the question algebraically more simple, but it's not strictly necessary, and we could solve it using W and R instead. How do we go about solving this question? Well, we need the tangency condition as well as the isoquant condition or production constraint. That's going to allow us to solve for the demand for labor and the demand for capital. That puts us one step away from a total cost curve. And the third condition we need to find the total cost curve is the sort of baseline total cost function. That total cost is equal to the wage times the demand for labor plus the rent times the demand for capital. So in my mind, solving for a total cost function is just one step farther than solving for the demand curves for labor and capital. Let's see how we go about solving one of these. So here's what we know. We have a production function, Q equals L times K. We have a wage of 40 and a rent of 10. We are trying to find the long-run total cost curve. Ultimately, we know we're going to set up a tangency condition and an isoquant condition and a total cost function. And in order to form that tangency condition, we need the marginal products. Now, the marginal product of labor is the partial derivative of the production function with respect to L, which is K. And we can also find the marginal product of capital as the partial derivative with respect to K, which will be L. This should be relatively familiar math. From these marginal products, we can set up our tangency condition. The tangency condition has the marginal product of labor over the marginal product of capital equal to the wage, which is 40, over the rent, which is 10. So just as a reminder, what is the tangency condition? This is us setting the magnitude of the slope of the isoquant, that's K over L, equal to the magnitude of the slope of the isocost line, that's 40 over 10. And that's guaranteeing that we're at this point of tangency between our isoquant and our isocost line. In addition to this tangency condition, which we'll call 1, we need to meet the isoquant condition or our production constraint. This question does not specify what the output goal is. That makes sense because we're ultimately looking for input demand curves and a total cost curve. So when we write down this isoquant condition, we're just going to set our production function, L times K, equal to Q, where Q is some unspecified output. We'll call that equation 2. And then finally, the addition here, if this was just an input demand curve question, these would be all the conditions. But because it's a total cost function, we have one more. To form that total cost curve, we need to understand the relationship between wage and rent and L and K. And so we're going to write this total cost function as total cost is going to depend on Q. It's going to equal the wage of 40 times L star of Q plus the rent of 10 times K star of Q. So I'm sort of writing down the structure I know that is going to exist for my total cost function. And after I solve for L star and K star, I'll just plug them into this equation to get my total cost function at the end. So I have my 3 conditions, tangency, isoquant, and total cost function. And I'm going to start by solving equation 1, the tangency condition for K. In particular, I'm going to figure out how K depends on L. Then I'll be able to plug that in and solve for L. So solving 1 for K, I get K over L is equal to 4 by simplifying here. And then I multiply both sides of the equation by L, so I have K is equal to 4L, and we can call this equation 4. The next step in the process is to substitute equation 4, the fact that K equals 4L, into the isoquant, equation 2. By doing that, I'm solving by substitution. I'm plugging in what I know about K so that I can solve for how L depends on Q. So I have L times 4L is equal to Q. I want to solve for L. In particular, I'm solving for L star, like the demand for labor. So I'm going to rewrite this as 4L squared is equal to Q. I divide both sides by 4, and I get that L squared is equal to Q divided by 4. I want to solve for L, so I have to raise both sides of this equation to the 1/2 power. And by doing that, I find my final answer that L star, which depends on Q, is equal to Q, oops, a little bit of lag in the recording, sorry everybody, Q over 4 to the 1/2 power. If you want, you can simplify this slightly. 4 to the 1/2 power is 2, so you could rewrite this as like 0.5 Q to the 0.5 power if you want to get rid of the fractions. So we have our labor demand curve. The next step is to find the capital demand curve, and the way we're going to do that is we're going to take our labor demand curve, 0.5 Q to the 0.5, and we're going to substitute it into equation 4, which tells us how capital and labor are related to each other. So I have K is equal to 4 times 0.5 Q to the 0.5. This math is quite simple. 4 times 0.5 is 2, so K is equal to 2 Q to the 0.5. And if you want to be formally correct, you would want to call this K star, and K star depends on Q. We can call that equation 6. We have reached our final step. We have a labor demand curve, we have a capital demand curve. All that's left is to plug those two demand curves into the total cost line, which is 3. I'm going to highlight that so we can see what I'm doing. So we know that total cost is defined as the wage of 40 times the labor demand plus the rent of 10 times the capital demand. So we just plug in what we know and simplify. So we have that the total cost, which depends on Q, is equal to 40 times 0.5 Q to the 0.5 plus 10 times 2 Q to the 0.5. Take a long look at this. 40 times 0.5 is 20. 10 times 2 is 20. So I have 20 Q to the 0.5 plus 20 Q to the 0.5, which means total cost, which depends on Q, is 40 Q to the 0.5.